Hi, I'm an old guy and I do maths. Here we have a really interesting puzzle. This is a field. It is 300 meters from there to there and 1100 meters in length. At 4 meters a second, the question is how long does it take us to get from A to P? The second question is, at 5 meters a second, how long does it take us to get from P to C? Now, I've done a little preliminary work setting this up because what we need to discover is we need to discover an expression for the length of this and also for the length of this, but initially for the length of this, A to P. And remember, we're doing this in terms of theta. We don't actually know the size of this angle, but we do know the size of some of the lengths here. Okay, so how would we normally find the length of this? Well, we'd have an angle here. We know this length, so we're in cosine territory. And I've set this up here. I've extracted the triangle. We're going to assume that this is all right angle territory. It didn't state that in the question, but when I saw the solution, it was predicated upon this all being a right angle triangle. If it's not, then it's a guessing game. Right, so we know that the cosine of theta is equal to the adjacent over the hypotenuse, which is 300 over AP. We rearrange that very, very slightly, and we get AP is equal to 300 over the cosine of theta. Now, that's the length of this. We know that this length is completed at the rate of 4 meters a second. That's velocity, it's speed. So we have distance and we have velocity. We're looking for time. There's a relationship. All we have to do is take 300 over the cosine of theta and divide it by our velocity, which is 4. And our answer is 75 on cos theta. That is how long it takes in seconds to get from A to P. Now, slightly more complicated, but using the same principles, we're going to discover how long it takes to get from P to C. Right. Now, the distance from P to C is 1100 meters minus BP. And so we should go looking for an expression for the length of BP in terms of theta. Now, if we do that, what we're looking at there is a tangent. This is BP here. This is theta, and this we know to be 300. So opposite over adjacent gives us the tangent of that. So the tangent of theta is equal to the opposite, BP, over 300. And a little bit of rearranging. BP is equal to 300 times the tan of theta. Now, we have a length for that. We have a length for this whole thing here. If I pull this down, we have, what I'm saying is we have a length for this, we have a length for all of it, and that this distance here is the total minus this, which we have here. So, our distance is 1100 minus 300 tan theta. And this is completed at 5 meters a second. Again, we have the relationship between distance, time, and speed, or velocity. And so velocity in this case is 5 meters a second. I'll put meters a second in here. I didn't in the previous example, but it is divided by 5 meters a second. And when we do that, what we get is we get 220, that divided by 5, minus 60 tan theta. That's how long it takes. Oh, in seconds. I beg your pardon. We should put in seconds. So that's how you do that problem in both its parts. Thank you very much for watching. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.